Hello friends, I welcome you in lecture number 19 on hypothesis testing. In this lecture, we are going to discuss about large sample test on the difference in population proportions. That is, we are going to compare two population proportions. So far, we were discussing only single proportion, and we have seen that if we want to estimate a population proportion by the sample statistic denoted by p hat, which is sample proportion, then the test statistic was z equal to sample proportion minus p divided by square root of p times 1 minus p divided by n. And if we are considering a sample of size n from the given population, and if this condition is satisfied, n times p is greater than 5 and n times 1 minus p is greater than 5, then sampling distribution of sample proportion is approximately normal, and this test statistic is a standard normal random variable. Now, instead of single proportion, we have two population proportions. So, we will see what is the test statistic for the sampling distribution of difference of two proportions. So, for that, we are considering two populations, and we denote them by population 1 and population 2. Suppose we consider two populations which we are going to compare with respect to population proportions. So here I consider population 1, population 2, and suppose population proportion for first population is denoted by small p1, that is a fraction of the population with particular characteristic. Suppose we are considering a sample of size n1 from this population, and suppose x1 is the number of elements in this sample with particular characteristic, and here sample proportion for this sample is denoted by p1 hat, and it is given by capital X1 divided by n1. Same thing here, this is population proportion for second population. We are considering a sample of size n2 from population 2. x2 denotes the number of elements in this sample of size n2 with the class of interest or with particular characteristic, and here sample proportion is p2 hat equal to x2 divided by n2. Now we are going to compare these two population proportions. So for that we will consider their difference. We want to check whether there is any difference between two population proportions or not. That is, we can consider this difference p1 minus p2 equal to 0. So there are three possibilities: difference is 0, or difference is positive, or difference is negative. So this is the way how we will compare two population proportions. So we will consider this sample proportion for first sample minus second sample proportion. This is going to be our estimator for this difference between population proportions. So we have to think about sampling distribution of this p1 hat minus p2 hat. Now if you recall, if we have a single population and if we are drawing a sample of size n from that single population, then if this condition is satisfied, that is n times p is greater than 5 and n times 1 minus p is greater than 5, then sampling distribution of sample proportion is approximately normal and its mean is equal to population proportion, and its variance is given by this formula. variance is not square root, this is variance of the sampling proportion is p times 1 minus p divided by n. This is the mean of sampling proportion. If we are considering sampling distribution of sample proportion for a single population, then the mean of sampling distribution is equal to population proportion and variance is given by p times 1 minus p over n if this condition is satisfied. So using this condition we can write down the mean and variance for sample proportions of both the samples which we have taken. So here if we continue in this direction, we have two populations and we have taken two samples of size n2 from those two populations. So on this side we are discussing for population 1. Just a minute. So here sample size is n1, population proportion is denoted by small p1. If this condition is satisfied, n1 times p1 is greater than 5, n1 times 1 minus p1 is greater than 5, then sampling distribution of p1 hat is approximately normal and the mean of p1 hat is equal to population proportion and the variance of p1 hat is equal to p1 times 1 minus p1 divided by n1. And same thing here I have n2 times p2 greater than 5, n2 times 1 minus p2 greater than 5. If this condition is satisfied, then sampling distribution of sample proportion for second sample, that is sampling distribution of p2 hat, is approximately normal and its mean is given by mean is equal to population proportion and variance is given by p2 times 1 minus p2 divided by n2. Now we are interested in this sampling distribution of the difference between these two sample proportions, p1 hat minus p2 hat. So for that we can say that if sampling distribution of sample proportion for both the sample is normal, then sampling distribution of this difference is also normal. So these two conditions are required for sampling distribution of the difference of sample proportion to be normal, and mean of this difference, that is p1 hat minus p2 hat, this is nothing but expected value of the difference of these two sample proportions. This is equal to, we know that expected value is a linear function, so we can write this as expected value of p1 hat minus expected value of p2 hat, that is mean of p1 hat which is small p1 and mean of p2 hat which is small p2. Okay, we are using these two things, that is mean of the sampling distribution of difference between sample proportions is equal to difference between population proportions. Similarly, we can write the variance of the difference between sampling distribution of sample proportions. This we can rewrite as variance of p1 hat minus p2 hat, and here we assume that these two samples which we are selecting from both the populations are independent. So if we have independent samples, then this we can write as 1 square, that is coefficient of p1 hat into variance of p1 hat plus coefficient of p2 hat, that is minus 1 square into variance of P2 hat. Now variance of P1 hat, that is this quantity P1 times 1 minus P1 over N1, and this is P2 times 1 minus P2 over N2. So this I write as P1 times 1 minus P1 divided by N1 plus P2 times 1 minus P2 divided by N2. So here I get the formula for the variance of the sampling distribution of P1 hat minus P2 hat, and therefore we can write that standard error of this sampling distribution P1 hat minus P2 hat, this is equal to square root of this quantity P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. So we will require these two things, standard error or standard deviation, and this mean of the sampling distribution of the difference of sample proportions. Now again we repeat that if these two conditions are satisfied, this condition means that sampling distribution of sample proportion for first sample is normal. This condition says that sampling distribution of this sample proportion for second sample is also normal. So these two conditions implies that sampling distribution of the difference between sample proportions is also normal, and therefore we can write down the formula for test statistic. This is equal to, our estimator is difference between sample proportions, this is our sample statistic, minus mean of this sample statistic P1 hat minus P2 hat divided by standard error or standard deviation of the difference between sample proportions. So from this we can say that if these two sampling distributions are normal, sampling distribution of P1 hat minus P2 hat is also normal, and therefore this is going to be a standard normal random variable, and now we can substitute these values here, and this is as it is P1 hat minus P2 hat, mean is nothing but difference between population proportions which we just derived, and this is also we have derived P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. This is the test statistic for testing the hypothesis related to the difference of proportions. Now suppose our null hypothesis is that two population proportions are equal, that is P1 equal to P2, or we can say that P1 minus P2 equal to 0, and we want to test this null hypothesis, that is we assume that null hypothesis is correct. Now if this is correct, then we can put P1 minus P2 equal to 0 here, and because these two are equal, we assume that suppose equal value is denoted by small p. So now in this formula of test statistic we replace this by 0, and here P1 and P2 are replaced by common parameter small p. So now we can see our test statistic becomes Z equal to P1 hat minus P2 hat, that is difference between sample proportions. This quantity is 0. Here I will put P1 equal to P. So I have P times 1 minus P over N1, and here also P times 1 minus P over N2. So this is P times 1 minus P divided by n1 plus p times 1 minus p divided by n2, and we can rewrite this denominator by taking that common quantity common from both the terms. So finally we obtain this formula or this form of test statistic for the difference between two proportions. So here this small p is equal to p1 equal to p2. We assume that null hypothesis is correct, that is two population proportions are equal and say equal value is small p. Now in given problems we will not be having the values of p1 and p2, and therefore we don't know what is this common population proportion is. So we have to estimate this common parameter using our sample data. So the estimator of this common parameter will be denoted by small p hat. Small p hat is the estimator of this common parameter for population proportions, and remember this we will find out by taking addition of x1 and x2 in the numerator divided by n1 plus n2. So we will replace this small p by this p hat, and therefore finally our test statistic for testing the hypothesis between the difference of two population proportions becomes z equal to p1 hat minus p2 hat. Here we write p hat times 1 minus p hat into 1 over n1 plus 1 over n2, and if certain conditions are satisfied, this is approximately a standard normal random variable. And what are those two conditions? One condition is that we have independent samples, and second condition is that sampling distribution of sample proportion is normal for each sample. If these two conditions are satisfied, then this test statistic is always a standard normal random variable, where we will remember this formula for estimator of common parameter, which is small p hat equal to x1 plus x2 divided by n1 plus n2. So this is the test statistic for testing the hypothesis on the difference between two population proportions, and using this test statistic we will discuss problems related to this in upcoming lectures. So this is all about this session. I hope you like it. Thanks for watching.